We're going to be now looking at Argand diagrams, yeah? An Argand diagram is what we use to represent complex numbers. It's like a graph, okay? Now suppose we want to draw the complex number z1 3 plus 2a, okay? If we look at our graph, we have an x-axis and a y-axis. Sometimes the x-axis is known as RE, which stands for real part, and the y-axis sometimes labeled as IM. Okay. So if we were to draw the complex number z1, 3 plus 2a, we would go 3 along, because 3 is the real part, which means it goes on the x-axis. So 3, and then 2a, imaginary part, 2, positive 2. So we'll go up 2 on the y-axis. So we're looking at somewhere here, okay? So that's z1. Now let's suppose we're drawing z2, which is minus 2 plus 5i. Okay, so we would obviously minus 2 is the real part. So you would see we would go minus 2 to the left. We'll find minus 2 on the real part. And then we'll go up 5 units on the imaginary y-axis. So we're looking at minus 2, what is it, 5? That's z2. Okay, let's say we are trying to draw minus 3i. So you get the point. We would basically find minus 3 on the real axis and then find minus 3 on the imaginary axis. And then we would plot our point. Okay. Now, there's something called polar form. And polar form is written in the form of r theta. Okay. R theta. Now let's look at the top 2 points. Okay, so let me get rid of this one here. So we're looking at z1 and z2. Okay, if we were to draw a line from these points to the center of the graph, let me use my ruler actually. Okay. So we have z1 and z2. This line is what we call our modulus, or r. Okay. And then our theta would be the angle subtended from that line, these lines, and the x-axis. So in this case, z1 that would be z1's theta. So let's call that theta 1. And then from here to here is what we call theta 2 for this line. Okay. Now to work out our values of theta for, let's look at z1 for example. As you can see, it's a right angle triangle, right? So if you were to find, let me draw this out here. So we have a triangle, we have our value, and we have something like this. We know these two values, okay? We know that from our complex number. We went 3 across to the right, so we have 3 on the bottom, and we went 2 up. So our unit for this side is 2. Forget about the imaginary part for now, but so we have 3 and 2. And we know from Pythagoras' theorem, to work out r, we would use 3 squared plus 2 squared, all square rooted, which would give us root 13. Okay, so we know our R equals root 13. And now we need to work out our theta. And to work out theta, we would use arctan 2 over 3. Or tan inverse 2 over 3. And we want our answer in radians. So we would get 0. So theta equals 0.59 to 2 decimal places. Okay. So if you were to write Z1 in polar form, we write Z1 in polar form, we would get root 13 0.59. And that is exactly the same as 3 plus 2. 3 plus 2i. Okay, now let's look at Z2, because Z2 is a bit more complicated. Okay, so let's look at Z2 now. Alright, so suppose you want to find out theta 2 here. And if you look at this, it is essentially a right angle triangle, right? So we could either look at it from this side. It's up to you from this side, or we could look at it from that side. We have to split it up, okay? So I'm gonna split it up from this side. So if I was to draw the triangle that I'm looking at a triangle like this, where this is our R value. And you can see here, this is not theta, by the way. This is just the angle here. I'm just going to call this X. And we know our values here and here from the complex number. So as you can see, we went 5 up on the y-axis. So this is going to be 5. And this here is, we're looking at just the unit, so forget about, we're just looking at the magnitude, yeah? So we're not looking at signs. So this is going to be 2. And using Pythagoras again, we can work out R, which is, R is going to be the square root of 5 squared plus 2 squared, which will give us root 29. So R equals root 29. So that equals now, that's root 29. To work out X, we'll then use what we know again, so R tan, or tan minus 1, T over 5 will give us our X. I remember we want it in radians, and we would get 0.38. 0.38. So now that we've worked out our R and we worked out X, this isn't theta, so we've got R. In order to get theta is the line is the angle between the x-axis and the line. So we worked out this little piece here. So what we now need to do is add 90 degrees, and 90 degrees in radians. Everyone knows 90 degrees in radians. It's pi over 2, right? Yeah. So we would need to add, in order to get theta, it's going to be pi over 2 at 0.38, which will give us 1.95. So now we've worked out our theta and we've got our, if we were to write that in polar form, we would get Z2 equals root 29, which is the same as a complex number minus 2 plus 5i.